Up next in our parent functions, we have the cubing function. So he has just a little bit more power than the squaring function that we just looked at. And as you can imagine, we are going to be plugging in those same key points, -2, -1, 0, 1, and 2. So let's cube each of these and see what we come up with, see if we can identify the shape. So -2 cubed is -8, -1 cubed is -1, then we get 0, +1, and +8. A little bit different from the squaring function, so let's see what we have. -2, -8, -1, -1, then 0, 0, 1, 1, and 2, 8. So now we need to draw a nice smooth curve that goes through these points. Now let me go ahead and caution you here. Please do not try to draw anything diagonally through there because that's not what it looks like. Right at the origin, this guy is flat. So I kind of exaggerate that. So he's flat and then he starts to curve up like that. And you do something very similar on the other side. You're flat and then you take this sharp turn as you go through those points. Okay, so this is your basic cubic shape, your cubing function. All right, now he doesn't have a vertex like we have for the squaring function. He doesn't have a line of symmetry. What he does have, though, is that he has this point of symmetry. So if I go to the right 2 and up 8, on this graph you also see that I go left 2 and down 8. That's how point symmetry works. You just kind of change the direction here. So left or right 1, up 1, go left 1, down 1, and you get another point. All right, so what about the domain? The domain will be the set of all x values used here. And just like the squaring function, you can plug in anything that you want to. So this is from -infinity to infinity. And what about our range? Well, I think it's pretty clear to see this guy goes all the way down. He goes all the way up. So my range is also going to be all real numbers, just like that. Now this is kind of an odd shape for us to get, but you know, we just have to practice with it, right? A lot of times we call this the cactus because it kind of looks like this, like some kind of cactus shape. All right, well, let's go on to the next one. The next guy we have is the square root function. Okay, so the square root function is going to be just a little bit different from what we've seen. Because I've got a square root, I know that my domain cannot be all real numbers. At least not when it's just the square root of x. This guy right here, when you think about your domain is saying that whatever's inside has to be greater than or equal to 0. So you can only plug in non-negative values like 0 and 1. So the square root of 0 is 0. The square root of 1 is 1. If I try to plug in 2, I'm going to run into a bit of an issue because I get the square root of 2, which is not a nice number. It's approximately 1.414. So this is where I need to be more selective about what I'm plugging into my function. Since I'm dealing with the square root, I should plug in numbers that are perfect squares so that I can nicely take the square root. So how about I plug in 4? The square root of 4 gives me 2. The next number after 4 that I want to plug in is 9 because the square root of 9 is 3. I'm dealing with the perfect squares. So let's plot these and see what we get. I have 0, 0, 1, 1. The square root of 4 is 2. The square root of 9 is 3. So unlike the other examples that we've seen where we're going from edge to edge of the graphing window and we're putting arrows on the ends, this guy starts at the origin and he just curves up and out like this. You only put an arrow on this end as he is going off the grid. Alright, so what is the domain? Well, we just said the domain is going to be where x is greater than or equal to 0. You see it here in the picture. So your domain is bracket 0 to infinity. And your range, as you go bottom to top, those set of y values that form this picture, the lowest he gets is 0, but he keeps going up and up. So that's bracket 0 to infinity. So this is the first case we've seen of one of our parent functions that has a restricted domain, and that's because of the square root. And it also leads to a restriction on our range. All right, know these key points, because that's going to be useful for us when it comes to graphing in just a little bit.